and his talk is going to be Advanced Remote Sensing Technologies for Powerline Mapping. And Sam, I see you've turned on your video.
I
So
have.
mine off, and I can hear you too.
All right, that sounds great. Thank you, everyone. Ron, great presentation. Appreciated that, a lot of your insights there. All right, everybody. So SolSpec here. Let me go back a slide. And SolSpec, the company that I work for, has been around officially for about 2.5 years. So we're not very well known outside of our client base. But we have been doing what we're doing for about 7 years under the umbrella of our sister company. And so I really kind of thought that I would start out just a little bit today, and I would give just an introduction of who SolSpec is. And then, when I am presenting to people, and for about the past 5 years, I feel like most people in the audience know who I am. So I thought I'd give you just a quick 30 seconds on who I am. And then, as Joe suggested, really just kind of trying to apply remote sensing to these different industries and kind of the different micro verticals within different verticals. Really, what we like to do and what I like to do is help people be successful with the technology that they're implementing. And so, I want to give a bit of an industry overview on areas where maybe companies could be making better decisions, and then to give tangible examples through some use cases on where we or I have kind of guided companies into a little bit of a better decision making here, and really with the understanding or the objective to apply this technology a lot more effectively inside of their organization. So really quickly, just a quick background on SolSpec. Like I said, we were founded in 2017, and we were founded from one of the nation's largest environmental reclamation companies. And so our sister company has hundreds of people out helping with slope stability, helping reclaim from a variety of different construction methods. And it really helps us learn these different verticals, learn these different industries, and learn the different ways that people are applying this technology. But we really took a bit of a divergent trend from our sister company when the number of companies we started to work with, they kind of demanded a little bit more of a canned solution, an out-of-the-box solution. When the volume of customers and the volume of acreage or square mileage we were working on really likened itself to ways that we could figure out how to scale our operations. And so at that time, we hired some people from some of the largest technology companies on the planet, from Google, have a person that was working on a SpaceX project, and really started to kind of embrace what we could do with machine learning, high performance computing, and whatnot. And then we have a whole bunch of kind of geoscientists or geospatial scientists. And so just to put a picture in your mind, we're the people that have skinny jeans, wear abrasive t-shirts, but we also have wool socks on with our divas. Right. So with that, who am I? I have been working in the energy world in GIS since 2002. I received my degree way back in 1996. So most of my team was born after I even started working in what I'm doing. In 2006, I started my own company. It was acquired in 2011. And then just at the end of last year, did I join SoulSpec. And so what I am doing, I'm Vice President of Operations, and I'm kind of bringing my knowledge and experience and maybe challenges that I've experienced and helping apply it to a team of highly capable people that are trying to do amazing things. I am definitely a work to live person. And so when you don't see me working or presenting, you'll see me on my bike, skiing, or spending time with my awesome family. All right, moving on here. So, for all of us that are technology geeks, we're living in a really exciting time, and just the number of technology platforms, data acquisition platforms, software and hardware systems, and how they're emerging. This is really, it's laying the foundation for, really for what SolSpec is doing, but also for what a lot of other companies on this awesome planet are doing, and providing value and insights that we didn't even think were possible not even a decade ago. We are in a spot where we have a lot of options in front of us, and these options really kind of confuse the market. So, all I want to do today is just kind of start putting some building blocks in place on things we can do to kind of unwind some of that confusion. With the host of different technology platforms on the market, I would be here way beyond my allotted time if I talked about all of them. So I'm keeping this in a relatively simple 4x4 grid, where I'm going to talk about acquisition techniques, and I'm really going to be focusing on aerial-based acquisition techniques, not taking anything away from terrestrial techniques, but honestly, my knowledge and experience isn't there to speak to it. So, but anything from drones to helicopters to fixed wing aircraft, and then up into some satellites, and really talking with what we're doing and how us and our partner companies or relationship companies are helping people be successful. And then as we think about these data formats, right, what are people getting out of the different types of either passive, kind of that 3-band or multispectral imagery, being able to talk about, get a picture of what's going on, but also run some analytics on the data that they're capturing. And then these more active sensors that we are seeing a strong adoption for now that our technology and our infrastructure is able to handle it. So things like LiDAR and things like synthetic aperture radar. All right, so getting into this just a little bit, as we're talking with customers and as we're working with different groups, we really kind of see companies, and if you think about, from a business perspective, really thinking about what the cost or what the investment that an organization is putting into technology, and then what's the value that they're receiving from that technology. And of course, as we kind of think about these plotting companies or plotting solutions in kind of a grid, you really come up with these kind of 4 quadrants. And really, just to walk through this really quickly, in kind of the bottom left corner here, this quadrant 1, really people that are dipping their toes in the water, thinking about deploying new technology or technology that's new to them for a project. And really what they're seeing is they've got limited investment and limited return, and they're at a bit of a standstill on what to do and how to move forward. Working into quadrant 2, we are working with a lot of companies right now that have invested significant dollars in remotely sensed technologies, but because they're not able to quantify the results, or maybe they're just implementing the wrong technology, executive leadership is seeing these projects as wasteful spending, and they're pulling back these budgets. And I think that any of us that are working in the budgeting cycle, especially in late 2020, are definitely seeing an impact from that. And so as we move over into this high value area of the grid here, quadrant 3 is where, maybe the company saw some benefits from that project, and they really want to start investing, but maybe there's some confusion. Maybe they want to make sure to be cost effective and cost conscious as they make these decisions. And then, moving into organizations that are absolutely reducing risk, absolutely working more efficiently, and saving money in the organization. Just one example that I want to give anecdotally before I move on is we had a customer who, based on our data, but also putting things into, and Ron kind of spoke to it. Once you get kind of 3 points of data from historical perspective, you can start to project into the future, or what people that do what I do or have done for the last 12 or 15 years, thinking about how we can start investing into these quantified and probabilistic risk models. And we had a customer who was taking our data and taking a bunch of other data, a pipeline operator. And when a huge storm came through the Appalachian region a couple of years ago, they actually made the decision to shut in a pipe that was at the cost of a couple $1 million per day, and actually found out that saved them tens of millions of dollars in the long run because the storm did negatively affect their right of way. So, quantifiable metrics on making decisions and making decisions that are helping the bottom line of the organization. So if we look at the companies that are kind of on the left side of that matrix, and the companies that are on the right side, and what are things that those organizations are doing on the right side that make their investment beneficial, they're really kind of following that old Stephen Covey 7 Habits paradigm of start with the end in mind, right? So they are looking at what questions that they want to have answered, and then asking a bunch of follow-on questions to make sure that they are deploying not only a data strategy, but a collection strategy that is going to drive successful results. Other things that we think about is frequency, right? We are walking this balance between budgets and effectiveness, and how do you get 3 to 5 data points per year without 3 to 5xing your cost on it and whatnot. And then can you get by with a passive sensor, or do you really need to make the investment in LiDAR or SAR, right? And then, of course, we're not making these decisions in a vacuum. So much like the anecdotal story I gave, what are the other platforms and systems that are in place, and what do we need to think about integrating the data that we have into those systems? Sorry, I've got an itch on my nose. Of course I do right now. So, really getting into this, I want to keep it simple. I want to keep us with 5 examples, and this is kind of going across the spectrum. Before I start into this, there is only 2 of these that we have directly been working with. One of them, Ron from the previous presentation, I've got an example from him here. And then another company that we've worked with up in Canada that uses satellite-based technology for much the same thing. So I'm really trying to draw a cross-section of different platforms and showing that there is just value across the spectrum here. So first and foremost here, as we're venturing into this world where we are embracing renewables, and where we're thinking about how we're going to be transforming a lot of what is traditionally ag land into solar and wind farms, we want to think about the process from soup to nuts, from getting your first permit to make the transition to ongoing operational costs. And we have been kind of part and parcel with our sister company in a lot of these solar farm projects, and have kind of felt firsthand, some of the benefits and some of the challenges as it relates to how technology is embraced to facilitate an effective solar farm project. So, through the construction process, you have a huge impact on what's happening with the long-term health and the long-term costs of the facility. Things as simple as how you grade and how you level out and how you revegetate can make the difference between being successful or not successful in one of these ventures. And so as we think about the new the introduction of the construction process, there's a lot of engineering activities that need to happen. We need to be leveling this field, making it as flat as possible, but we're also taking into account the vegetation, different threats that can happen from the environment, whether it's erosive qualities, channeling, whatnot. And then we also want to be monitoring the construction effort. But then after the solar farm is created or constructed, we want to have the ongoing management, and we want to be able to do that as effectively and driving those bottom dollar prices down as much as possible. So assuming or as organizations are looking at embracing remotely sensed technology to manage these type of projects, we get a lot of questions about coming on board and flying drones. The one thing I did not mention as I was in my data collection techniques slide is through this presentation, I am actually not going to be talking about drone-based LiDAR. And the reason I am not is there's a lot of change going on in the industry right now. And I feel like anything that I say today, based on my knowledge from the last quarter, is probably going to be invalidated in just a couple of months. So I do know there's drone-based LiDAR out there. I do know there are companies that are embracing it. I am not referencing it here. So companies want to start collecting this baseline. They want to acquire data. And due to the geographic area, they really focus on how can I put a drone up and how can I start getting data from the drone to start driving some of my management practices. And even though this geographic region really kind of falls inside of that optimum range for a drone, we find that it's very challenging to get that true ground model derived from that digital terrain model, or what we will call a vegetation off ground model, from the collection parameters that we have, and then understanding the topography at a detailed level, at that engineering grade level, but then also establishing a baseline so you can bring down those ongoing operational costs. So as we are being pulled into efforts where we are assessing the viability here, we are thinking about an aerial-based LiDAR system with relatively low fidelity for a LiDAR collect, in that sub 30 points per square meter, but also being able to collect true 4-band imagery, so we can create that strong baseline, with survey points. You can get a very accurate representation of the ground. And the other thing that we find in doing this is flying that initial baseline and maybe spending a little bit on the initial collect actually allows you to more easily and more accurately deploy something like a drone-based LiDAR as time goes on, as this construction project goes on. And then, thinking about an annual, or maybe at worst a biannual LiDAR collect, to really start looking at how erosive measures are taking effect on the land, and also how vegetation health is on kind of rehabilitating this. And why would we advocate from somebody going from drone 3 or 4 band or multispectral data to like a fixed wing or a helicopter based LiDAR here? And it's because that medium fidelity LiDAR is really at this size and this scale, it's nominally more expensive than a drone. but it also is providing a pretty highly accurate representation of the ground. And then establishing that baseline, like I said, will allow you to come back in with lower price solutions moving forward and really try to do that kind of incremental monitoring. The second example here to talk about is a rural utility that is looking for a vegetation management program. And in my experience, and I maybe other folks around here have had the same experience, is that utilities, when you think about the size and then the data needs that are happening inside of a utility, that helicopter or that higher resolution based LiDAR is really poised to provide the value from the investment in that collect, being, you're typically getting a higher fidelity data product, and you're typically able to do more analysis with it. However, when you look at the unique constraints of more of a rural utility, you find that you have these large expanses of geographic area, a larger kind of asset footprint. And you also are looking at a kind of a reduced number of use cases that you want to deploy this technology for. And, in this example, we're looking at vegetation management. So for that, it's really important to get, a very, very good picture of vegetation structure, but then also be able to derive kind of the age, the size, and then as you add this multispectral imagery in, vegetation health. One of the things that I jotted down from Ron's presentation was, the challenges of doing change detection on vegetation. And you're absolutely right. Trying to do change detection on vegetation is hard, but if you can limit that change down to a couple different attributes, then it actually becomes a little bit easier. So we are actually doing change detection on vegetation structure and vegetation health, and so not thinking about all of the change that can happen there. So, in this scenario, the client was really, they were going to forego what could be a beneficial product because they were looking at bringing in, they were pricing themselves out of the project. They were looking at something that was going to collect a very high accurate, very highly resolute data. They didn't need it to solve this problem. And they were also looking, just operational costs by the time it takes to collect and the resolution that they need to collect with, they were, it was going to be cost prohibitive. So the solution was to work on a fixed wing based LiDAR data collect. So just like a Cessna 206 with a LiDAR sensor in it, and then a multispectral camera as well. And pulling that out, and if you look at the image on the right there, that's actually the data from the proof of concept project that was done. And that example, we were able to derive where power lines were, maybe not classify exactly what the power line is, able to derive where support structures were, maybe not classify exactly what it was. But we were able to get a very strong vegetation structure, vegetation height, and vegetation health model and help optimize what that vegetation management plan would be. And so why did this create value? Because they did get to cut costs from their kind of legacy system that was extremely manual or extremely subjective through just surveying flights or surveillance flights, I apologize. And then the data systems or the data that we pulled out of this project actually gave them enough information they need to move forward. So moving on to the next use case here, and this is actually supplied by Geo1, and this actually rolls right into the 5G rollout, and looking at how LiDAR can actually help you scale and help you cut costs through these projects. Right. So 5G has been a huge talking point for a lot of us lately. We know there's a lot of investment going into it in the coming years, but we also know that we can't act fast enough, we can't roll it out fast enough, and we really need to assess the suitability of the current infrastructure to help make that happen. So rather than manually assessing different support structures, rather than sending a manual team of individuals out, this high fidelity, highly accurate LiDAR data collect can actually create a lot of cost and time efficiencies in the effort and help you scale out operations really fast. So, the solution and really kind of helping to drive the value in this solution is to consider a high fidelity LiDAR product where you can fly at a relatively low elevation at a relatively low speed. However, it's giving you the fidelity and the resolution to identify and classify not only the power lines but additional equipment on the line and do further analysis with this data to find, load, being able to assess load on the line itself, or being able to optimize the location of the 5G antennas and their power source. So, why is this an efficient or a more efficient operation than kind of the legacy method or the status quo? Well, it really comes down to flat out cost and scalability, right? As you can fly more land, more ground, you can classify more data through these advanced technologies, then you can get to your answer much quicker. And then when you couple artificial intelligence and machine learning with kind of that human component, you're really able to get to that answer a lot faster. Next, we think about the environment that we live in, and we think about how that affects our asset infrastructure, but also the operational costs that go into the management of just the land that our assets live in. And this is actually a project that we did as a company and have worked with this organization for many years. And you'll see right here, and if my mouse is visible here, you'll see that we have kind of an indentation in the ground right here. And this example is a client that was spending an inordinate amount of money every time it rained. Any type of environmental breaker they put in place would fail. And so they were reactively going out and repairing this to the tune of tens of thousands of dollars, every incident at every rain event. And they employed a remotely sensed solution to this. But if you look there, and so right here is an example of a change detection metric, and the colored area that we see in my screen is actually the footprint of where they were employing their kind of remotely sensed data collection and data analysis. And with this, they could tell where things were happening, but they weren't able to tell why it was happening, right? They weren't able to get to the root cause. So what did we do? We actually flew a much larger geographic area, and we did a complete suite of analysis on this region, including being able to do a very elaborate hydrologic flow model. And you'll see here that all of the water on this slope was draining into their right-of-way that they had constructed, and it was pooling on the backside of this right-of-way. And then it was channeling out over their right-of-way, and just like water does, finding that least cost path of resistance, and it was costing them tons of money. But until they had an idea of what was happening on the backside of their right-of-way, they would have just constantly been chasing after repair work and mitigation work. And because you're taking the human component and the subjectivity out of this, the algorithms that we run also detected a landslide that was forming downslope of that So, and anybody who works in the industries where they're looking at the environmental and civil effects of the landscape around their assets, there's usually a 10, 100,000 factor to, it costs me tens of multiples of dollars to go fix something before it's an issue. It costs me hundreds of multiples of dollars or hundreds of thousands of dollars to go fix it once it's an issue. But I'm talking millions the minute that fails and you have an outage or your service is interrupted. The last example here is actually an example through a company called 3V Geomatics that embraces this technology called INSAR, which is satellite-based synthetic aperture radar. And as you think back about kind of those questions that I was mentioning before, frequency is one of those factors that can really drive an effective system and effectively using these systems. And in this scenario, there was a dam failure and a mining operation. This is a tailing pond. A dam failure. The dam was being monitored through both flight monitoring and through human monitoring, and it failed. And the cost of this failure was to the tune of $800 million per day of lost productivity. But you can also imagine the environmental impact, the cost to repair this, and the ongoing impact to either public perception or shareholder price once one of these events happens. And so the following was actually done as a post-mortem on what would have happened had we invested in a remotely sensed technology earlier rather than later. And what they found is they actually took data from the previous, I believe it was 6 or 8 months, and they performed change analysis on it. So those who aren't familiar with satellite-based INSAR, we're really looking at about 10 meters of resolution, so not super resolute. However, capturing data between 8 and 15, I believe, days around the entire globe, so very high frequency. And when you start looking at this information, you can start seeing very quickly where there is a lot of change. And in these two examples that you see, you'll see a big red blob of change. That was actually an active mining operation, so expecting a lot of change there. But then you kind of see these bands of red, and this is actually where erosion is happening. And as a byproduct of this, they found that there was detectable change that was going to result in a failure, notice 7 months prior to this happening. And they also had determined that had they employed this technique, they would have been alerted 3 times in the previous 6 weeks that something was happening. So, the benefits here is, the ability to deploy a technology that is going to give you a high frequency of data to do your analysis from, but also accepting that lower fidelity is just fine for this type of analysis, really enabling you to deploy a much more resolute technology if you want to learn more. And then, you have to admit that no matter how expensive a vendor is, $800 million a day is a pretty hard hit to an organization. So it's probably cheaper than the alternative as well. So that's the end of my presentation. I just want to thank everybody for coming and follow on by saying that we do have a lot of technology available to us. Listening to the presentations today has been it's just been amazing for me to listen to how different companies are employing this. And these different technology bundles can really help us solve these complex problems. But if we take a step back and if we think about what we're trying to answer by deploying these technology types, we could really kind of come up with a plan that is going to help us be more effective with what we use or what we employ. And just a plea to everybody to embrace these different types of remotely sensed data and all work to create a safer and more sustainable planet. So thank you. Joe, I am done.
Thank you, Sam. Very interesting talk.
Now I take a drink.
I think it's the kind of talk that kind of ties the day together really well, because it doesn't matter which of the activities you might have been thinking about doing or are doing in the as was reflected in the previous talks. I think you give us some context for how to be thoughtful about using these technologies and putting them into practice, and also understanding the benefits. I really like the synthetic aperture radar example, because the typical response from a lot of people is 10-meter pixels. Well, that couldn't possibly help me.
Right.
And yet there's the example, and it's a really good example because it costs them so much to deal with it. And that's what it is, because when you start incurring those damages, it's too late for you to be having regrets or trying to figure out how you could have done it. And it was a great example because they had historic data, so they could actually look at what in the world was going on in there. So in this,
Joe, not to interrupt, I apologize, but a way that we like to think about things is, when you have a person on the ground doing work, you are getting the most direct feedback on what's happening. It's also about the most expensive and about the most time consuming. And the thing that we have been hearing a lot of lately too is it grows the risk, right? Because people get hurt, right? And it seems that every step you move away, your costs can definitely go down. Oftentimes the resolution of the data goes down, even if you talk about going from a person on the ground to a helicopter to a fixed wing to your satellite. However, if you use these in concert with each other, you can really figure out where to deploy the more expensive option at a more precise scale.
very, very well put.
Yeah.
And I know, having been around some of these tailings ponds, it's not pretty walking around them, especially in the areas where you need to be if you are visually inspecting them, in terms of the danger to yourself and the kind of team you need to have to support you, so that you're not doing this as a loner. And if people are wondering, those of you who are in the power generation or power distribution space, think about you don't need tailing ponds. You can have your sedimentation ponds or your fly ash ponds and so forth. And that's only a very simple example, because you just step sideways just a couple of feet. The real issue with innovating when you have technology like this is really letting loose with your imagination and figuring out all the problem areas you have, and kind of running through the list. Just today, not just Sam's talk, but running through all the talks today and thinking about, could these technologies be applied and what would the benefit be? So we do have a question from Stacy. You talked about frequency. How long does it take to process and turn around the data of each of these collection methods? So that's a good question, because you talked about several.
Yeah, great question there. I think one of the things that I learned this morning, and I think it was the DOT example. You're always a bit amazed at what people are doing and how people are turning around data. So, I really think kind of the panel of participants today could answer this independently. This is what I will tell you. So you know, with solutions out there like Pix 4D, you know, drone-based imagery or aerial-based imagery, you can almost turn it around in days. I mean, of course, there's a lot of caveats that go there. We have been focusing on LiDAR and more specifically, large area collects of LiDAR. So for example, our company just collected about 5,000 square miles of data in the Appalachian region. It took us about 2.5 months to collect all of that data, and have also been collecting a couple thousand square kilometers of data in Canada. And what we're doing in that is doing multiple collects per year in these regions and trying to get into that probabilistic model on different types of a probabilistic risk model, I should say, on different types of threats, whether it's well, I'm not going to get into that. To answer Stacy's question on the time, so you know, we were struggling for years on the weeks or months it took to create actionable intelligence out of a LiDAR collect and a multispectral collect. So I mentioned that we hired some engineers from some pretty advanced companies, and so we captured and collected that 5,000 miles of data in Appalachia and had full point clouds, classified point clouds, plus multispectral imagery, plus all of our decision-ready analytics turned around about 2.5 weeks after collect on all of that data. So, you know, whatever that time frame is that is happening with these different types of technologies, you know, we're finding that going down every day. I know that the examples with the INSAR data, it's not necessarily the resolution of data that's causing the pain, it's the volume of data. They're making a trip around the globe about every 10 days, right? And so at that point, you just have huge volumes of data that you're working with. So I know they really try to pull out actionable areas and do analysis on those actionable areas. Then they can have the other stuff take a while to process. So, you know, I hope I answered the question well, but that's my thought.
So just a subsidiary question. INSAR is a relatively new technology. Some state governments are finally jumping on the bandwagon. Where do you get your INSAR data from? Is it a government agency or private company?
Where do we get our data from?
Yes.
So we don't really work with INSAR data directly. We work with 3V Geomatics, and they work with there's a Japanese space agency, and as I say these words, understand I'm exhausting my knowledge on INSAR. They are working on L-band INSAR through the Japanese Space Agency, and I can get anybody in contact with 3V if you're interested in learning more.
Yes,
so
that would be good. So I have a couple of questions, even though we've kind of hit bumping up against the time slot for you. So where do you see the adoption of remote sensing providing the most value to a company? How do you work that calculation?
Sure. Yep. So from my perspective, and like I mentioned early on, I've worked for the last 10 or so years trying to help drive more effective risk models. And everything that we see is regulatory agencies, underwriting agencies, insurance, they are trying to predict the future. And as we can start to combine data types, as we can start to normalize data structures, and when I say data types, I'm thinking from different sensors, as we can start to normalize these data structures, and as we can increase the frequency by doing the two of the before, we can start getting that predictive look into the future. And that personally, that's where I see the biggest benefit happening. Right? If we can stop things happening before they happen, right?
Yep, being able to see the future.
Yep.
So speaking of seeing the future, what do you see as the emerging technologies in the remote sensing world? I realize what's emerging can be different for different people based on their vantage point. But I think we all at least know about LiDAR.
Yep.
We know about optical imaging. What do you see as the emerging technologies in the remote sensing world?
Yeah. So again, kind of mentioning what I talked about before, I think that a variety of sensors that can work to help optimize where you are deploying these more resolute technologies. And I mentioned before, my not really approaching drone-based LiDAR, because it's changing so much right now. However, I really think that the collection platforms that we're putting these different sensors on. So if I was to say three things, the thing that I missed as well is the hardware and software that can help us manage, store, and make use of this data. Right. So emerging technologies, hardware and software, collection platforms, and integrations of different technologies.
Very, very true. Thank you. So, so I have one final question to ask everybody who's a presenter here. They're more than welcome to answer this. So feel free to turn on your video and your microphone. But this is a question that came up pretty early in the conference from Robert. What are the concerns of clients as to defects in your deliverables? In other words, if you don't find something that could be actionable but was missed in your work as a provider of technology or provider of a service, where's the liability? Who has the liability? And when it comes to contractual terms, how is this handled? Anybody want to comment on that? Because I think
I've got the camera. I'll take my first stab, and then I'll turn my camera off and let somebody else jump in. Right. So we thank lawyers, and we thank lawyers through our contracts that we supply data, and you action on the data. And so, we do what we can, and we do what we can to help. But we are just a tool in the equation. But the other thing that I would say is, when you are able to develop a relationship with a client and you walk through why you've delivered what you have delivered, you really start to unwind and start to unravel that confusion, or you increase the trust in which that data is handed off and delivered. So, as a data provider, we admit that we can't find everything, but we help our customers walk through everything we can find.
Thank you. Anybody else want to comment? I see Ron, Brendan, and Justin are still here with us. I'll give you just a few minutes. If I see you switching on your cameras, then you have the floor. Doesn't look like anybody's rushing towards answering it, so I'm just going to move on to wrap up the conference. So I want to start by thanking everybody again for attending, and also everybody who has presented at this conference. I also want to particularly thank the attendees who sent in such great questions. I think your participation is invaluable, and I hope that that you were able to get your questions answered. And of course, we have a solution if it wasn't. So let me just talk about going back to the guidebook, and make sure that you do have that link, and remember that you can download the document if you wish. But in the guidebook, if you go to the detailed schedule, you'll see watch the archive video come alive. Can't tell you exactly what day or time that will happen, but give us a couple of days, so you can go back and look at look at any of these presentations. You can fast forward through them, and so forth. I also want to ask you to please look at the other events that are coming up. I mentioned them early on in my presentation, but the next asset mapping event is called GNSS Advancements for AEC, and this one is just next week. It's on Wednesday and Thursday, September 9th and 10th, and you go to assetmapping.events/GNSS, and then you can learn about the other events that are coming up on the calendar, and they're not all up there. So go back and check it from now and again, so that you can find out about what's coming up, and you can then enroll in those courses. My part is almost done. I want to just say that I think it's been a great conference. We had a wide range of information presented from many different areas. And the interesting thing is they all came together in a very nice way. Different people come from different backgrounds, have different needs, have different roles in their businesses. And I hope that you all were able to take something away. And don't forget that when you have the guidebook, if you see someone in your organization that needs to hear someone's talk, you can simply point them to the video replay. As one of you just wrote, the big problem with a virtual conference is we can't all go to the bar afterwards and get a beer. But what we're all going to do is go home first. Don't drive after you ingested the beer, but go home first and then have a beer and reflect on a great day. And with that, I'm going to close by saying thanks again to our sponsors, Geo1, Bad Elf, Compass Data, Trimble, SolSpec, Overstory, and GeoLearn. We're very grateful to all of you. This conference would not have been possible without your contributions to allow so many people to attend. And with that, I will bid you good day.